Hi everyone, welcome back to this series of project management key concepts where we're delving deeper into the project management body of knowledge. And this one in particular is the critical path method and calculating float using the forward and backward pass. This is something that can really trip people up and is something that's also good to know for your general project management activities and also for the PMP exam. So first of all, we're assuming that you understand what float is, which is basically float is any leeway that you have or any wiggle room that you have in the project schedule. This is an example project schedule down here. We've got activity 1, 2, 3, and 4. And this is on our critical path method and our schedule network diagram where we're describing the different times for our schedule. For example, the early start of this activity, the early finish, the activity name, the duration of that activity, the late start, the late finish, and finally the float or leeway that we have in that particular activity that leads to any leeway that we have in the overall project schedule. So what is the forward and backward pass? How are we going to do this? Well, when finding our critical path, which is the path that has zero leeway, and this is on our schedule network diagram that we just saw, we first need the early start and early finish times, and we do that via the forward pass. So that's our first step. Then our second step is our backward pass. So that's how we get the late start and late finish times. And then to finally calculate float, we look at the difference between the late start and the early start. And the critical path ultimately is the path that has zero float on all of those activities. Now the best way, even though that's quite a little bit to take in, so the best way is to go through an example, and this will really help. So first of all, we want to enter the durations of each activity. How long is it going to take, even if it's an estimate? This one we've got 5 days, 5 days, 15 days. That's their durations. This one is 10 days a duration. Now that we have that, we can perform the forward pass, which is all of our early start and early finish times, as we were saying. So we've got our early start on the left and our early finish on the right. And the way we figure this out as well is once we've got our first early finish, we add 1, and that's our next early start. So we've got 5 plus 1 is 6 is our early start. 15 plus 1, that's their highest. So the highest previous early finish of 15 plus 1 equals 16 on our schedule network diagram. Once we have the early start and finish times, we can get the late start and late finish times via the backward pass. And the way that we do that is we enter the highest early finish in the last box. So obviously this one only had 1, so we had 30, and 30 is where we're sitting for our late finish times. Now we minus the duration, so 30 minus 15 plus 1 equals 16. So that's how we get the late start for this particular one. And we're doing the backward pass, so we're working backwards. That's right. Now we take the late start and we minus 1 again. So we've got 15 minus our duration of 10 plus 1 equals 6. And again, the lowest one here is what we want to use, minusing 1 to give us the 5 for our late finish there, and minusing 5, which would give us 0, plus 1, which will give us 1 for our late start there as well. Now finally, with all of that information, we can now calculate float. And this will help us get the critical path on our schedule network diagram. So float is the late start minus the early start. And you can see down here, we've got late start is this one, minus the early start, which is this one. So 1 minus 1 equals 0. 6 minus 6 equals 0. 11 minus 6 gives us 5. So we have a little bit of project float or leeway or a bit of wiggle room for that particular activity. But we don't have any for this activity because it's still 0. And on the final one, we have 16 minus 16 gives us 0 again. So there's no wiggle room for this particular activity. So if we know that the critical path is the path with no wiggle room on it, then we can say that the critical path in this case is activity 1, activity 3 to activity 4. And we can also say that this activity up here might be able to be delayed by 5 days if we absolutely have to. Now that is the idea of the critical path method on your schedule network diagram, using the forward and backward paths to calculate float and any wiggle room in your project schedule. It's a bit of a mouthful, isn't it? But we got there. Thanks for watching, guys.